Hello. In this video, I'm going to show you how to use serialization to pass R objects from one execute R script to another within the Azure machine learning environment. Azure ML allows you to pass a data frame as a rectangular record out of an execute R script module to other modules within Azure ML. However, a data frame must have columns of uniform length. In other words, you can't have a ragged array in a data frame. There are situations where you'll need to pass an R objects which are not rectangular between execute R script modules. For example, you may wish to pass R model objects, R functions, R lists, or even lists of lists from one execute R script module to another. Specifically in this video, I'm going to pass a list of R model objects from one execute R script to another. If you're familiar with R, you know that you can compute a model object and then apply a predict method to the model object for any new data without need to recompute the model. To do this in Azure ML, you will need to compute the model in one execute R script and apply the predict method to the model in another execute R script. By serializing that model, we can pass it between those two execute R scripts. There is an article at the URL shown that contains additional details on serializing and passing R objects. There's also the code I'm going to use for this demonstration and the data. If you'd like to follow along, I suggest you download these now. Also, the models I'm going to use in this video have already been discussed in a previous video on R time series models. If you haven't seen this video, I suggest you do so now. There's also additional information on these models in the Quick Start Guide, which is also available at the URL shown. Alright, let's get started. I have on my desktop here the Azure Machine Learning Studio, and I also have RStudio with the code I'm going to use for this discussion. You can see I've already started an experiment here, given it a name. I have my California Dairy Data CSV dataset on the canvas. I also have an execute R script module on the canvas. And I've already cut and paste into this execute R script module the same code that I discussed in the transformation and time series modeling video I already referenced. So at this output port here, when we've run this, we have our data ready for analysis, same as before. So let's add another execute R script module to this project, and we'll connect it to that transform data output. And I'm going to go to RStudio and show you the code we'll use in that module. This first part here is identical to what I've already discussed in the previous video. And here are the two models, one for the trend model and one including the seasonal terms. What's new here is we're going to create a list of these two R models and then serialize them. I have here a function that does just that, serializes a list of R objects. There's quite a bit of defensive code, as you can imagine, trying to test whether the inputs are what we believe they should be. The main work is done in this line of code here. You see, we serialize a list, and there's a first element called the number of elements, which is the number of elements in the list, and then a payload, which is our serialized list. Notice that we convert this all to a type integer. Serialize outputs as a raw type. And Azure ML doesn't recognize that type, but if we coerce it to an integer, everything will work just fine. So we've created a data frame with one column called payload, and we output that from this function. Now here we call the serlist function with a list with our two models, milk.lm and milk.lm2, and we get back a data frame, and we output that data frame. So let's give this a try. I'll cut and paste this code to this execute R script module here, and I'll run it. The experiment looks like it's run successfully, so let me visualize the output. And here we have the output, which has one single column called payload and a bunch of numeric values, which aren't really human interpretable because remember, this is a serialized list of R model objects. Now that we've successfully serialized our list of models, I'm going to add another execute R script to my canvas here, and we're going to unserialize those models and make some predictions from them. So I'm taking the serialized list of models as an input to the dataset 1 port on this execute R script, and the transform data I'm going to input to the dataset 2 port. I'm going to go back to RStudio here, and I have the code for this execute R script prepared and tested. On port 1, I get a data frame I'm calling model frame, and that's going to have our serialized list of models. And on port 2, I have this data frame CA dairy data, which is our transform data set. Now I have this function called unSerialist that I've created. Again, it has some defensive coding, but the real work is done here. So we coerce the payload column of that incoming data frame to raw with as.raw, and then we apply unserialize and assign it to outlist. Here we check that the number of elements was greater than 1. If we had 0, then that means we failed on the serialization. Next, I'm going to test that these models are actually of class LM. See, I test that in these two little blocks of code here. If they are, I assign them to these much handier names. The rest of this code is identical to what we discussed before in the previous video on time series modeling. Notice that I'm making predictions in these two lines of code with our two linear models that we've extracted from the serialized list of models. And we'll make the same plots and diagnostic plots as before, compute the RMS error as before, and output the RMS error. So if everything goes well, this should have results that exactly agree with what happened before. So let me copy and paste that code into this execute R script here. And now I'm going to run the project. Well, it looks like it ran successfully, and if that's in fact the case, we should see the same graphs that we created before. Yes, here they are, the same set of time series plots, the same set of diagnostic plots. Good. And let's have a look at the RMS error values. And again, they're exactly identical to what we had before. Let me quickly summarize what we've done in this video. In this execute R script, we computed two linear models and then serialized the list of those models in output. In this execute R script, we unserialized and extracted those models from the list, and we made some predictions. Just to remind you, this is a very general process. We did this with two linear models, but it could be any set of models. It could be R functions. It could be lists. Well, I hope you found this video interesting, and I hope this will help you construct interesting machine learning models with Azure ML. Thank you and goodbye.